Today we're going to take a look at graphing quadratics in standard form. We should be on page 8 in your note packet. So standard form, our general equation is y equals ax squared plus bx plus c. Our vertex is negative b over 2a and then y, which we'll talk about how we get that vertex in a minute. And then we have our axis of symmetry. So this equation is x equals negative b over 2a. That is an important equation to make sure that you know. So star that. Okay, so standard form for number 1, f of x equals 2x squared minus 8x plus 6. So f of x, think of it like a y. So we've got ax squared plus bx plus c. So our a is 2, our b is negative 8, and our c is 6. Those are important values to identify because we're going to need them to find our axis of symmetry. So that's the first thing we're going to do, is find our axis of symmetry. So we have x equals negative b, so negative 8 becomes a positive 8, all over 2 times a, which is 2. So we have 8 over 4, which is 2. So our axis of symmetry is a line, so we have to write it as an equation, so x equals 2. So go ahead and go to your graph and do a dotted line at x equals 2. So we know that our vertex is going to fall on that line, x equals 2. So that 2 is actually our x value in our vertex. Now we have to find our y. When we know the input, how do we figure out the output? Well, we just plug the 2 into our equation. Once we calculate that, so 2 times 4 minus 16 plus 6, we should get a negative 2. So now we can go to our axis of symmetry, which was x equals 2, go to negative 2, and that is our vertex. From there, we're going to use our table from our parent graph. So 0, 0, 1, 1, 2, 4. And we know a is 2, so we're going to go ahead and multiply our y's by 2. Starting at your vertex, we're going to go ahead and plot the 1, 2, so go to the right 1, up 2. Go to the right 2, up 8. Then we can reflect those points and sketch our quadratic. Now we can go ahead and answer the information that is required. So it opens up because our a is positive. We have a minimum, and our minimum value is negative 2. This is a vertical stretch. Our roots are the same thing as our zeros. So that is going to be a 1 and 3. Our x-intercepts, write your zeros or roots as an ordered pair. So 1, 0 and 3, 0. Our domain is all reals. And our range, our lowest value for the y's is negative 2 to positive infinity. Our end behavior is x goes to the right. What's our graph doing? It's going up. And as x goes to the left, what is our graph doing? It is going up. Our increasing and decreasing intervals. Our increasing interval, remember we use x values for both, so we're increasing from 2 to positive infinity, and we're decreasing from negative infinity to 2. Now this notation may be new to you, but think of this as y equals 0. So basically they're asking for your x-intercepts or your roots, your zeros. So that is going to be a 1 and 3. Now over here, the c. If we take a look at our graph, our c was 6. Take a look right here. That's our y-intercept. Let's take a look at number 2. Y equals negative x squared plus 4x minus 2. So the first thing we're going to do is find our axis of symmetry. X equals negative b over 2a. It's always good to identify our a, b, and c. So our a value is really a negative 1, our b value is a 4, and our c is negative 2. Plugging that into our formula, x equals negative 4 all over 2 times the negative 1. So negative 4 divided by negative 2 is a 2. So our axis of symmetry is x equals 2. Going to go ahead and put our dotted line on the graph. So we know based on that 2 that our vertex is going to be 2 something. We're going to take that 2 and we're going to plug it in. So y equals negative 2 squared plus 4 times 2 minus 2. Calculating that, so we have negative 4 plus 8 minus 2 gives us a positive 2. Now using our table from our parent graph, 0, 0, 1, 1, 2, 4, and our a value, which was negative 1, we multiply our y's by that negative 1, then we can go ahead and graph. So this is our vertex, it's like our 0, 0. Now we're going to go to the right 1, down 1. To the right 2, down 4. And we're going to reflect those. Also, if you remember our c value, that's our y-intercept. And we did cross at negative 2. And now once we have our graph, we can go ahead and answer our questions. This opens down. And why does it open down? Because our a is negative. Do we have a maximum or a minimum? Do we have a high point or a low point? We have a high point, it's our maximum, and what is that value? It is a 2. Do we have a vertical stretch or shrink? We don't, we just have a flip. And then our solutions, where does it cross our x-axis or our x-intercepts? They're not nice numbers, so we're going to go ahead and use our calculator. And we're going to calculate the zeros. So if you have a graphing calculator, go ahead and take that out. If you don't have a graphing calculator, just follow along and see what I do on mine. So in our graphing calculator, we're going to go ahead and go to the y equals, and you're going to type in your equation. So negative x squared plus 4x minus 2. We're going to go ahead and take a look at the graph. So as you can see, our graph should match what we have graphed on our paper. And now we're going to calculate our zeros. In order to do that, you're going to go second, trace, so it goes to calculate. Then we're going to go ahead and go to number 2, which is 0. Hit enter. Now it asks for left bound and right bound. The reason is because your graph has 2 zeros, so you have to tell the calculator which 0 you want to calculate. So we're going to go ahead and calculate the right 0. So I'm just going to make sure that I am left of where I think that 0 is and hit enter. Then I'm going to go ahead and click right, go past that, go right some more, hit enter, and then it asks for a guess. So get close to that 0 and hit enter. So that 0 is approximately 3.4. So one of them is 3.4. But there are 2, so we're going to go ahead and we're going to do that process again. So you go second, calc, number 2 to 0. Now I've got to go all the way left. You want to make sure you're left of it. Hit enter. Go to the right of it. Hit enter again. And then guess, so get close and hit enter. So the other one is approximately 0.59, or we could say 0.6. Next unit, we will learn how to actually calculate the zeros with our equation without using our calculator. Taking a look at number 3, this is an inequality, so we have to make sure that we remember what kind of line we're going to have and where we're going to shade. But the process of graphing is the same before. So let's first find our axis of symmetry. X equals negative b over 2a. So we've got negative 2 over 2 times 1. So our axis of symmetry is 1. So go ahead and put our dotted line at x equals 1. Now with our axis of symmetry being 1, we know that our x and our vertex is also 1. So now we've got to plug that 1 into our equation. We could just set it equals because we want to find the y value. So we're going to have 1 squared minus 2 times 1 minus 8. 1 minus 2 minus 8 is going to give us negative 9. So we can go ahead and graph 1, negative 9. Now if we remember, that negative 8 is our y-intercept, so we can also graph that point and reflect that point. We should always write our parent table, so our 0, 0, 1, 1, 2, 4. Our a is 1, so we do not need to multiply our y's by anything, so we can go to the right 2, up 4, and reflect that point. We can also do our next point, which would be 3, and then 3 squared is 9, and reflect that point. Based on our inequality, we're going to have a dotted or dashed line. And our shading, since it is less than, is going to be below. To answer our questions, it is opening up. We have a minimum value at negative 9. Is this a vertical stretch or shrink? It is neither because our a is 1. And then a point in your solution set can be any point in the shaded region. So an example could be negative 5, 0.